Alright guys, Mr. Mice is coming back to you with inverse functions, and I'm going to talk about first my part one. This is going to be two parts, but part one I'm really only going to talk about some of the basic ideas of what inverses are, an inverse of a function. And then in my second video I'll do actual problems on how do we determine the inverse of a function algebraically. Okay, so let's just take some time here to talk about what inverses are. So the inverse of a function is a function itself, or a relation. Sometimes it's not a function, and we'll determine that in just a second. But it's a relation that switches the domain and the range. So the domain and the range of our function, our inverse is now going to be the range and domain. So we'll switch it. The x and y are now going to be the y and the x. So it switches, and I'll show you what I mean. So let's take a look here. I have a function, and this is just a function of points. 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. My inverse function, which in this case it will be a function, we'll want to know for sure if it's a function or not. F inverse, now we put an inverse with a negative 1 right above, kind of like a power, but it's not a power. So some of you that were in Algebra 2 or class before, and you know that a negative 1 power is really the reciprocal. It's not the same with functions. This is just a notation for inverse function, okay? So the inverse function is going to be the set of points, and we're going to just switch these guys, okay? 6, 1. So what was the y is now the x, what was the x is now the y. Okay, so we're just going to switch these guys all the way through. 8, 3, 9, 4, 10, 5. All right? So in inverses, all we do is switch, and we can see this as a mapping as well. A mapping is when we have like a bubble here and a bubble here, and then we map something to another thing. Well, we're just going to switch the domain and the range. So just remember, we're switching the domain and the range. We're switching the x and the y for inverses. So what does that look like graphically? Well, we'll look at this graph here. I have y equals x cubed. And y equals x cubed, it looks like this, and I plotted a few points. I plotted 1, 1, negative 1, negative 1, 2, 8, and negative 2, 8. And let me go ahead and zoom in on this for you so you guys can take a look. It might be a little easier for you guys to see it that I'm zoomed in here. So what I'm going to do is I'm going to take and draw the inverse. Now I already know that the inverse is the cube root of x, and I'll show you just in a second how we determine if two functions are inverses of one another. But to do that, so to do this, we're going to graph this, and all we're going to do is we're going to plot our points. So remember, we're going to switch 1, 1. We switch it, and we get 1, 1. So 1, 1 is going to stay the same. And then we're going to take negative 1, and switch that, and we get negative 1, negative 1. So 2, 8 now becomes 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8. And up 2. All right, so now we got that one right there. And negative 2, negative 8 now becomes negative 8, negative 2. 8, down 2. And our function looks like this. Okay, so this is our inverse. And you can see that there's kind of a symmetry going on between the original function and its inverse function. In fact, I believe the symmetry is y equals x symmetry. So we can kind of, we kind of turn and flip it is kind of what happens. All right, so that's how we graph the inverse from its original function. I suggest taking a few points. Now, a couple other things that we want to make sure, and I'm going to zoom out again so we can see the rest of the board. Okay, big head's in the way here. So a couple things that I want to mention is that a regular function here, can be called one-to-one. And a one-to-one function is a function in which the values of the domain map to exactly one value in its range. Alright, so that means it's 1 to 1. 1x for every 1y. 1y for every x. There can't be any doubles, okay? There can't be any repeats. So what does that look like? And how do we determine if something is 1 to 1? Well, I often use something called the horizontal line test. And the horizontal line test will determine if something is 1 to 1. Determine if a function is 1 to 1. Now, why would we want to know if a function is 1 to 1? Well, it turns out that if a function is 1 to 1, then it has an inverse that is also a function. Okay, so if a function is 1 to 1, then the inverse is a function. Okay, so how do we determine if something's 1 to 1? Well, we'll take a look at the graph. Alright, so I've got another graph here. This guy off. And I've got here y equals x squared and its inverse y equals plus or minus x. Now I know that I already know the inverse, so that's why I wrote it up here already. But notice here that if I took similar to the vertical line test, remember the vertical line test tells us if something is a function. So if I took my horizontal line and I move this horizontal line up through my graph, I hit that graph twice. It crosses at 2 points, which would tell me that y equals x squared is not 1 to 1. It's not 1 to 1. So if it's not 1 to 1, the inverse is not going to be a function. And we see that right here. This is its inverse. If we did the vertical line test on the inverse, we would see that that pretty much is not a function, right? So in order for the inverse to be a function, the original function needs to be 1 to 1, okay? And we can test that using the horizontal line test. All right, last thing I want to show you is something that we often have in terms of the definition of inverse. In some books, you'll see that the definition of an inverse is that f of g of x is equal to x, and g of f of x is equal to x, then f and g are inverses. That's kind of nifty, right? The composite functions, if we take the composite functions of each and we just get x, which is the identity function, we're going to get two inverse functions. So how do we determine if two functions are inverses? Well, we can take and we can basically look at their composite functions. So what I'm going to do is I'm going to take my two functions, my one function that I knew from the previous graph over there. I'm going to have f of x equals x cubed and g of x be equal to the cube root of x. And I'm going to see if these two are inverse functions, are inverses of one another, okay? So the first thing I'm going to do is take f of g of x. So I'm going to take f of the cube root of x, and I get the cube root of x cubed. And we know that the cube root of x cubed, these guys kind of cancel out, is x. Alright, so I'm going to do it for the other one, g of f of x. G of x cubed is the cube root of x cubed, and I have a similar situation here, which is x. Now, be careful because it works here with the odd powers, but with even powers, it doesn't always work because of a negative and positive situation, which I probably will talk about in class a little bit, see what you guys think about it. But be very careful when you're taking the square root of x squared, okay? Alright, so there we go. That's my intro to inverse relations and inverses of functions. I'll be back with a part 2 video showing you exactly how to find the inverse of a function using some algebra, okay? Bye.